Greetings, my dear students. Today I'd like to familiarize you with the portfolio performance measurement, that is Jensen's measure of differential returns. As the name indicates, in Jensen's measure of differential returns of portfolio performance evaluation, we are finding the difference between the actual returns and expected return. And for calculating the expected returns, we are using the capital asset pricing model equation, which we already discussed in the previous sessions. Okay, so the steps involved in Jensen's measure of differential returns are: first one is using capital asset pricing model formula, find out the expected return of a portfolio. As per capital asset pricing model, expected return of a portfolio is equal to RF plus beta P into RM minus RF. Here RF means risk-free rate of return. Beta P is the systematic risk of the portfolio. Then RM is the market return. Then the second step is to ascertain the actual return of the portfolio. And the third step is to calculate the difference between this actual return and expected return. Significance of Jensen's measure. If differential return is positive, it indicates that superior return has actually been earned due to better management of risk. If differential return is zero, it indicates neutral performance of portfolio management. A negative value indicates that the portfolio performance has been worse than that of the market. That means the performance of the portfolio management is worse. Here we can calculate Jensen's measure of this question. The question is, from the following, evaluate the portfolios based on Jensen's measure. Here we have given two portfolios, A and Z. Actual return of portfolio A is equal to 12% and actual return of portfolio Z is equal to 19%. And beta factor of portfolio A is 0.7 and beta factor of Z is 1.3. Market return is 15% and risk-free return is 7%. So firstly, let's calculate expected return by using capital asset pricing model equation. The equation is expected return of portfolio is equal to RF plus beta P into RM minus RF. Here in this portfolio, in the case of portfolio A, RF is equal to 7, RM is equal to 15. It is same for both the portfolios, and beta factor of portfolio A is equal to 0.7 and beta factor of portfolio B is equal to 1.3. So we can calculate expected returns by applying this equation. Expected return of portfolio A is equal to 7 plus 0.7 into 15 minus 7, that's equal to 12.6%, and expected return of portfolio B is equal to 7 plus 1.3 into 15 minus 7 is equal to 17.4%. Now we can calculate differential returns by applying the equation actual return of portfolio minus expected return of the portfolio. Differential return of portfolio A is equal to 12% minus 12.6, that's equal to minus 0.6, and this 12.6 was given in our question. And differential return of B is equal to 19% minus 17.4, that's equal to 1.6%. Jensen's differential return of Z is more than that of A, so Z is a better portfolio. Okay, so I am concluding here. Thank you.